Hello everyone. In the previous video we have learnt about the tangents to a circle. Now in this video we will learn about different positions of two circles and also about the common tangents to the circles. How many common tangents can be drawn to two circles when they are in different positions? First of all, we will learn about the different positions of two circles, what they can be. Let's learn about that. See here, first of all, we find when two circles are away from each other, like we are finding here two circles, one is with center O, another with center O dash. They are not touching each other, they are not intersecting each other. The second position may be when they come near to each other. We can understand this like this, that we have pulled this particular circle towards this and it is touching it at one point only externally. The centers of these are O and O dash. Like these circles are touching each other at point P. Suppose we bring them some more near, what will happen? They will intersect each other at 2 points. Like here you find these two circles with center O and O dash, they are intersecting each other at A and B. This becomes the third position of two circles. Now suppose we bring them some more near. In that case, one of the circle will be lying inside the other circle and touching it internally. Like these circles with center O and O dash, they are touching each other internally at point Q. And now suppose we pull it some more towards this center of the circle, what will happen? It will be lying completely inside the circle without touching. There may be two positions having the common center and different radii. Or it may be that their centers are also different, radii are also different, but even then they are not touching each other and one lies inside the circle internally. We will discuss about these all 5 positions one by one in this particular video now. Now we learn about the common tangents. Common tangents means what? Common tangents to two circles are those tangents which are the tangents for both the circles together. So how many types of common tangents we have? We will also be learning about these all the cases, all 5 cases what we have just now learnt. How many common tangents can be drawn and what are the different conditions for the circles to be in these 5 positions. So watch the video till last, and if you have not subscribed it so far, subscribe it. Let's discuss about the common tangents now. See, suppose these are two circles we have with center O and O dash. We can draw the common tangents like this is a common tangent and the points, we call them what? We call them the points of contact. So A is the point of contact at this circle and B is the point of contact at this circle. It means this is a tangent to both the circles, and that is why it is a common tangent to both. This is another one which is intersecting or touching at C and D. So these are the two common tangents which are the tangents for both the circles. These tangents are known as direct common tangents, like the one AB and CD. What about the other one? We can also draw the tangents like this. One is intersecting or touching at P and Q. Another is intersecting this at R and this at S. It means the points of contact of these circles are P and Q for this particular tangent and R and S for this particular tangent. What are these known as? These are known as transverse common tangents. Sometimes we also call them as indirect common tangents. Like here we are having PQ and RS. Now we will come to all the 5 positions of different circles and draw the common tangents to them. We will learn what are the different conditions for them to be in these 5 positions, and also what is the number of common tangents can be drawn to them at them. Now we will learn them in detail one by one. The first position of 2 circles we have when they are away from each other. Like we have here 2 circles. One is COR1, means center is O and the radius is R1. Another is CO-R2, means the center of this is O dash and the radius is R2. They are away from each other. So what is the condition? We can see here, if we join the centers of them, the distance between their centers OO dash is greater than the sum of their radii. So we find the condition here, OO dash is greater than R1 plus R2. How many common tangents? See, here we have AB and CD. These are 2 direct common tangents. So number of direct common tangents, we have 2 in such case. How many are the transverse common tangents or indirect common tangents? They are here PQ and RS. So 2 are the indirect or transverse common tangents. So the number of that is also 2 here. So total number of common tangents in such case will be 4. The second position of 2 circles may be when they are touching each other externally. Like here we have 2 circles, one is COR1, another is CO-R2. Here what we find in this case? If we join the centers, here we find OO dash is OP plus O dash P, that is R1 plus R2. It means we find that the distance between their centers is equal to the sum of their radii. What about the number of direct common tangents? Here we find AB and CD are 2 direct common tangents. So the number of direct common tangents in such case is 2. Whereas the transverse common tangent is XY, which is touching both the circles at point P. It means the number of transverse common tangents, that will be only 1. And so we can say that there are only 3 common tangents in such case. The third position of the circles is when the circles are intersecting each other at 2 points. Like here we have 2 circles. One is COR1, another is CO-R2. Here we can see that OL, this is R1, and O-M, this is R2. What becomes the condition in such case? The distance between their centers OO dash, we are finding, is less than the sum of their radii. So O dash is less than R1 plus R2. They are intersecting each other at P and Q. If we join P and Q, then what is PQ known as? PQ is known as the common chord of 2 circles. What about the number of direct common tangents? Direct common tangents here are AB and CD. So we have direct common tangents 2 here in this case. What about the indirect or transverse common tangents? Can we have? No. So there is no transverse common tangent, that is number is 0. And hence there will be total number of common tangents in such case as 2 only. The fourth position of circles is when one of the circle is lying inside the other one and they are touching each other internally. Like here we have 2 circles COR1. It means the center is O and radius OP is R1. Another circle is touching it internally, that is CO-R2. It means O-P is R2. So what becomes the condition in such case when they are touching each other internally? That is the distance between their centers OO dash. We find here is OP minus O dash P, and that is R1 minus R2. It means the distance between their centers is equal to the difference of their radii. What about the common tangents? See, direct common tangent is only one, that is xy, which is touching at P. So number of direct common tangents is only one. Can we have any of the indirect or transverse common tangent? No. So the number of transverse common tangents is 0. It means the total number of tangents in such case is only 1. The fifth position of two circles is when one circle lies completely inside the other circle. We can have two cases of it. That is, they are concentric circles or they are having different centers. Concentric means the center of them is same, only radii are different. In such case, what you find? Suppose we say that the circle are COR1 and CO dash R2. In that case, the centers O and O dash coincide. And if the centers coincide, it means the distance between their centers is 0. And 0 is less than R1 minus R2, the difference of their radii. Other case is when the centers are different and radii are also different. But the circles are not touching each other, not intersecting each other, and one is lying completely inside the other. In that case, like we are finding here, COR1 and CO dash R2 are two circles. OP is the radius of the larger circle, that is R1. O dash Q is the radius of the smaller circle, that is R2. Here also we find that OO dash is less than R1 minus R2. It means the condition for such position becomes that the distance between their centers O dash is less than the difference of their radii. What about the common tangents? Can we draw any common tangents, whether it is direct or indirect or transverse? No, there is no possibility of drawing any of the tangent in such case. So there is no common tangents in such cases. And we can say there are no common tangents possible in this case. So there are no common tangents. So in this video, we have learnt about the different positions of two circles. And in all the cases, we have learned the condition also, in what condition that particular position will exist. And also we have learnt about the number of common tangents to them which can be drawn. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.